Okay, students, today what we're going to do is go through the unit circle. This is page 740 in the Carnegie book. So this is what I want you to do. I want you to turn to page 740. You have this exact drawing. I'm going to show you how to fill it out, how to do the calculations. Okay, you're going to fill it out on this sheet. After you've done this on the video, on your sheet, then you're going to go ahead, close your book on this, and come up and get a blank one of these. And I want to see if you can go ahead and replicate the exact same thing. This is major. You're going to use this in Algebra 2 a lot, pre-calc. I expect you to know this, calculus. Okay? In Algebra 2, you will get a blank one of these like this as a quiz. So you can think of this as like a practice quiz for an Algebra 2 quiz you'll eventually have at some point in Algebra 2. Okay? So here we go. Unit circle. Unit circle means the radius is 1. We got a circle with a radius of 1. Now, so unit means 1. You should remember from our degrees, we have right here 0 degrees, 90 degrees, 180 degrees. Oh, I can go ahead and fill them in right here. Then what degrees down here. Okay. Halfway would be 45 degrees. Another 45 plus the 90 is 135. Another 45 plus the 180 is 225. And your 270 plus another 45 is 315. That's going around by your 45 degrees. These other ones are all 30s and 60s. So 30 degrees, 60 degrees, 90. Another 30 is 120, another 30 is 150, another 30 is your 180, another 30 is your 210, another 30 is 240, another 30 is 270, the next 30 is 300, and the next 30 is 330, and then we're back to 360, or 0 again. 0 and 360 being the same thing. So, as we see there, counterclockwise is positive degrees. Clockwise would be negative degrees. Negative 30, negative 45, negative 60, negative 90, etc. if we were to go clockwise. Okay? Now, what we just got done doing in this lesson earlier was to work on our triangles drawn in quadrant 1, 2, 3, and 4. Remember, this is quadrant 1, 2, 3, and 4, right in the order of our degrees, going from 0 to 360. Okay, remember we drew our triangles in each quadrant and put our signs, whether the x or the y is positive, and the hypotenuse is always positive. X and y are positive or negative depending on the quadrant. Okay, remember this is the origin right there, 0, 0. Okay, so now to convert, we talked about converting from radians to degrees before and degrees to radians. We've already been tests on that, but as a quick review, 180 degrees is pi radians. 180 degrees equals pi radians. Remember, the degrees is around the circle like this, how many degrees you're moving, whereas radians is the distance around the circle, part of the circumference. Okay, so if I go all the way here, that's 3.14, etc. radians. That's the distance. Okay, so that's the difference again, as a reminder of the difference between radians versus degrees. Okay, so very simple pattern. Everything in this here is about patterns. You only have to know a few things, a few key things, and the rest is just patterns from there. So pay attention to the pattern, learn it, memorize it, and you'll pop this out easily. Okay, so how do I go from 180 degrees to 30 degrees? I divide by what? Everybody should know, 6. So that means whatever I do to 1, if I'm dividing by 6 here, I need to divide by 6 there. So that means this is pi over 6 radians. Okay, that's simple. So every 30 degrees is 1 pi over 6. So if I go to 6 degrees, that's another 1 pi over 6. 1 pi over 6 plus 1 pi over 6 is 2 pi over 6. Okay? Well, remember, we need to reduce our fractions each time. What's 2 pi over 6 reduced to? Pi over 3. Now that should make sense because if I took 180 and divided by 3, I would get 60 degrees. That means every 60 degrees, every time I go 60 degrees, I'm doing 1 pi over 3 more. So if I want to jump to 120, 60, the next 60 is 120. 1 pi over 3 plus 1 pi over 3 is 2 pi over 3. If I jump another 60, 120 plus 60 is 180. What's 3 pi over 3? And isn't 3 pi over 3 equal to 1 pi? And there's your 1 pi right there. If I was to jump another 60 degrees, that'd be 140. So from 3 pi over 3 plus another 1 pi over 3 makes it 4 pi over 3. Add another 60 degrees to 240, that makes it 300. And I add another pi over 3 to 4 pi over 3, that makes it 5 pi over 3. And I add 60 degrees to 300, it's 360. And I add another pi over 3, makes it 6 pi over 3. And 6 pi over 3 is equal to 2 pi. That same thing works for your 30 degrees. 1 pi over 6, 2 pi over 6, 3 pi over 6 for 90. 3 pi over 6 reduces to pi over 2. Then I have 4 pi over 6 for the 120, which reduces to 2 pi over 3. 5 pi over 6 for the 150. 6 pi over 6 for the 180, which 6 pi over 6 is 1. So again, that's why it's 1 pi. Another 30, 7 pi over 6, therefore for 210. 240 would be 8 pi over 6, and 8 pi over 6 reduces to 4 pi over 3. 270 would be 9 pi over 6. 9 pi over 6 reduces to 3 pi over 2. Then I would have 10 pi over 6, but that reduces to 5 pi over 3. Then I would have 11 pi over 6, which doesn't reduce, so that's 330. Then I would have 12 pi over 6, which reduces to 2 pi. So I can go all the way around the circle with the 30 degrees and pi over 6, and just keep adding on one more pi over 6 all the way around, and then just make sure I reduce it. Okay, so the same rule, same type of pattern would apply with 45 degrees. How do I get from 180 divided by what gives me 45? Well, it's divided by 4. So that means pi over 4, every pi over 4 is 45 degrees. So if I start at pi over 4, I add another 45, that's 90 degrees. That makes it 2 pi over 4. Well, what's 2 pi over 4 reduced to? Pi over 2. I add another 45 degrees. Remember, that was 2 pi over 4, so now I go to 3 pi over 4. I add another pi over 4, which is 180 degrees, 4 pi over 4, which is 1 pi. I add another 45 degrees, now that's 5 pi over 4. I'm just adding 1 pi over 4 each time. And if it reduces, I must reduce. I add another 45 degrees, that's 270, that's 6 pi over 4. 6 pi over 4 reduces to 3 pi over 2. I add another 45 degrees, I remember that was 6 pi over 5 pi over 4, 6 pi over 4, now we're at 7 pi over 4. That does not reduce, so it's 7 pi over 4, and I add another 45, that's 8 pi over 4, or 2 pi. Okay, so there's your pattern. Real simply, just adding 1 pi over 6 each time to every 30 degrees, or 1 pi over 4 each time to every 45 degrees, and then you just must reduce it if it reduces. Okay, simple pattern there. All right, so now we want to talk about their x and y coordinates right here. Now, I mentioned before, I'll just put it down here, the x coordinate is cosine, the y coordinate is sine. Okay, tangent, tangent would be y over x. Sine divided by cosine is tangent. Okay, some unit circles will have a third spot to put tangent in there, and they'd have you divide the y divided by the x. This does not have it. This just has the x and the y coordinates to put in there. Okay, so notice every one of these is either a 30, 60, 90 degree triangle or a 45, 45, 90 degree triangle, unless it's right on the 90 degrees. Notice or 0, every 0, 90, 180, 270. Remember, unit circle means it's 1. So at 0 degrees, I want out 1. The radius is 1, so that's why you have 1, 0. I add 90 degrees to it, right there, straight up. That point is 0, 1, because the radius is 1. I go 180, I'm going left 1, because the radius is 1, so negative 1, 0. Remember, this is the origin right there. And then go down 1, that's 270, 0, negative 1 is that point. Okay, So don't forget, every x coordinate is the cosine. So what that is saying, for example, the cosine of 270 would be 0. That's the x coordinate. So cosine of 270 would equal 0. The sine of 270 is the y coordinate, which is -1. That's how this works all the way around when we fill these in. Okay? Every x coordinate is the cosine of that degrees or the radians. Every y coordinate is the sine. And then tangent would be taking the y divided by x. So in this case, tangent is y, -1 divided by 0. Can we ever divide by 0? The answer is no, so it's undefined. So the cosine of 270 is undefined. Okay, so now we need to go and fill in our 30, 60, 90 degree triangle as we draw it one time, and a 45, 45, 90. And it's up on the word wall on the board as well, but I'll go ahead and do it down here. So if I have a right triangle, 30, 60, and 90. Now, as we know, our relationship for 30, 60, 90 is a root 3, and 2a. You should already have that memorized. If I make a 1, this makes this 1 root 3, and this 2 times 1 is 2. Okay? Now, remember, the 90 degree side is the radius. That's the radius. And see, notice our radius right here is 2, isn't it? This is the easiest way to me to come up with the actual values, is just use 1, 1 root 3, and 2. But now I have to go backwards. I know the radius on the unit circle every time has to be 1. So notice right now it's 2, isn't it? Well, how do I get from 2 to 1? I divide by 2. So whatever I do to 1, I must do to all of them. So therefore, at 30 degrees, we have sine. We have 30 degrees is 1/2. 6 degrees is root 3 over 2. And the radius is 1. So at 30 degrees, so you can think of this. Let's change the color. Let's go to red. Okay. So if I'm just doing one example right here. This is 90. That's 30. So if I was to take that triangle I did, so that would be 60 up there. If I was to take that triangle I just did, I would have had a 1, a 2, and a root 3, right? But remember, now I have to divide each by 2 to get down to a radius of 1. So what is my x coordinate? Here's my x coordinate right here at 30 degrees is root 3 over 2. What's my y coordinate? I went up 1/2. Okay? So now, and this is what I'm going to do all the way around. Every time it's 30 degrees, remember the 30 degrees goes along with its opposite side. Opposite the angle is the side. This is the 60-degree side. And of course, the 1 will always be the radius. Unit circle 1. Okay, so what is this saying? This is saying, remember the x coordinate is cosine. So that means the cosine of 30 equals root 3 over 2. You don't have to write this down, I'm just letting you know. Remember, and sine is the y coordinate. So the sine of 30, because again, this is the reference angle. The sine of 30 is the y coordinate. 1/2 right there. Okay, and if I was to do the tangent, remember the tangent means it's y over x, which would be 1/2 divided by root 3 over 2. Remember that becomes multiplication by the reciprocal. The 2's cancel, but then I'm left with 1 over root 3. Can't have a radical in the denominator, so I must rationalize it. And I get root 3 over 3. That would be the tangent of 30 degrees. Okay? So, now what you're just need to do is go ahead and fill these x and y coordinates. So every time, if we do all the 30, 60s now. So remember, if I go to this next 61 here, okay, and drew that, remember this would be 6 degrees. Well, opposite 60 every time is root 3 over 2. There's my 60 there. So the x coordinate here is root 3 over 2. And of course, up here would be 30. Opposite that would be the 1/2 every time. It's not changing. Okay? So there'd be 60 degrees. Now, why are they both positive? Because they're in quadrant 1. Remember, any triangle, the x and the y coordinate is positive. That's why we get to them practicing that before this. Okay, so every time it's opposite the 60-degree angle, it's going to be root 3 over 2. Every time it's opposite the side that's opposite the 30-degree angle, it's going to be 1/2. The only difference is what the sign is, positive or negative. That's going to depend on the quadrant. So if we go over here at 120, remember this is 60 degrees, isn't it? The reference angle is 60. So that goes to the y coordinate. So the y coordinate is the 60-degree one. What do we say the 60-degree one is? Root 3 over 2. And since I went left, that's negative. And then the y coordinate is positive. Remember I said put your signs first? Oops, sorry. 30 is right here. So the opposite of that is 1/2 every time. So it's negative 1/2. And the 60 degree, which is the y coordinate, is root 3 over 2. And that's positive if I went up. Okay? So if I wanted to, I could write down here, for example, every time, I have it right here. 60 degrees is root 3 over 2. Every time I have the 30-degree side, it's 1/2. And the only difference is whether the sign's positive or negative, depending on your triangle in that quadrant. So on each of my 30s and 60s, I could just be filling these in and just putting the positive or negative on it. So let's go to the next one in quadrant 2. Again, we're still going to have negative and positive. Okay, so at 150 here, we know it's negative and positive. Put your signs in. This reference angle right now, the 150 is 30 degrees. What's always opposite 30? 1/2. Ah, dang it. That makes it the y coordinate. Keep forgetting. And then this reference angle, or the non-reference angle up here is 60. So that's root 3 over 2. Every time it's 60 degrees, it's root 3 over 2. Okay? I come down here to quadrant 3, and I know they're both negative for the x and the y coordinates. This reference angle is 30 degrees at 210, right? So that's the y coordinate is 30 degrees. Side, so that's 1/2, which makes root 3 over 2. The 60-degree side is my other one, which is the x coordinate. I come over here, 240. That's my 60 degrees up here. So that's the y coordinate. So again, both negative. The 60 degrees is the y coordinate, which is root 3 over 2 every time. 30 degrees for the x coordinate, so negative 1/2. I come over here, I got positive and then negative for quadrant 4. Put my signs in first. Okay, this reference angle at 300 is 60 degrees right there, right? So then the 60-degree side is the y coordinate. So the y coordinate, root 3 over 2, the x coordinate, 1/2. And then at 330, the reference angle is 30, so that's the y coordinate. Again, we have positive and negative. The y coordinate is 30 degrees, so that's 1/2, then 60 degrees for the x coordinate, root 3 over 2. Every time 60-degree side is root 3 over 2, 30-degree side is 1/2. Each time. All its things that on every one, right? 30 or 60. The only thing that changes is your signs on what quadrant that point is. Remember, you're always starting from the origin right there. Now, if you're only having to do one of these, I would just draw the triangle in that quadrant like we did in our homework. We were just doing all this at one time in the unit circle. Okay, so now the only ones we have left to fill in are the 45, 45, 90s, right? 4 to go. 1, 2, 3, 4, one in each quadrant there. So if I go back to now 45, 45, 90, I know the relationship is A, and A root 2. So if I say it's 1, 1, and then it'd be 1 root 2, right? But remember, our radius has to be 1. So I'm going to make this 1, which means I need to divide by root 2. That will give me 1. Whatever I do on one, I have to do on all of them. Okay, so now this equals 1. Remember, I can't leave it as 1 over root 2. I need to rationalize that. So multiply root 2 over root 2, and I get root 2 over 2. So each of these is root 2 over 2. Every time. On every 45, 49, root 2 over root 2 for both the x and the y coordinates. The only difference is what sign based on the quadrant. So real easy on the 45, since it's positive and positive, in quadrant 1, root 2 over 2, root 2 over 2. Quadrant 2, we know it's negative, comma, positive. Root 2 over 2 doesn't change each time, root 2 over 2. Quadrant 3, we know they're both negative. Negative and negative, root 2 over 2, root 2 over 2. And quadrant 4, we know it goes positive, negative. Root 2 over 2, root 2 over 2. Okay, so to me, that is the easiest way of doing it. If you watch a YouTube video, sometimes they'll try to teach you like some song that goes along with whatever. I'm not into music, so I don't get into that stuff. I just use simple logic, common sense for x and y coordinates, what quadrant they're in. It's easier to me to use common sense and work on memorizing some song that might help you or whatever. Okay, so we have filled this out, everything on here, all the degrees, the radians, and then the x and y coordinates. Like I told you, if you want to do tangent, you do the y coordinate divided by the x coordinate. Tangent is y divided by x. So just take the y coordinate on each one, divided by the x coordinate, and simplify it because no radicals in the denominator, and that would be the tangent. Okay, and then of course, we have the reciprocals of each one. We know the reciprocal of sine is cosecant. The reciprocal of cosine is secant. The reciprocal of tangent is cotangent. So I would just take whatever those values are and do the reciprocal of them. Okay, if I wanted the other of the 6 total trig functions. All right, so now I want you to come get a blank sheet of this, close your book, and for you to go back. You don't need to write any of this stuff down right here if you don't want. You could just go down to what we did down here. Okay, draw it one time out, or write your relation. You don't even need to draw the triangle if you don't want it. You can just write 30, 60, 90, write down this. A root 3, start at 1, 1 root 3 and 2, and then divide each by 2 to get down to 1 for the radius. And do the same thing again right here. Okay, start with that, and then break it down. You get root 2 over 2 for each one for the 45s. And again, the only difference is make sure that you put your signs in first, positive and negative for the x and y coordinate. Then you won't blow it. That's the biggest thing that students blow it on, as I've already told you before, is their signs. Okay, now the other thing just to remember is when I look at the reference angle 30 degrees, remember that goes along with the opposite side. That means that's the y coordinate. So this reference angle, that 30 degrees, whatever the reference angle is right there, is always the y coordinate. And then therefore the other one, the 60, if it was the non-reference angle was the 60, that's the x coordinate every time. Okay. All right, that does it.